have to draw an efficient frontier, then you need to have at least know how an efficient frontier look like. Sebagai contoh, kalau saya kata kelas sila lukis gambar ayam. Jadi nak lukis gambar ayam, first you need to know how ayam looks like, isn't it? Kalau tidak, you might draw something weird. Okay, sebab tak nampak gambar ayam. Atau lukis gambar apple. Okay, apple tak pernah jumpa. Okay, so you don't know how to draw an apple. Jadi, efficient frontier. If you ask orang dekat jalanan, no knowledge of finance, cuba lukis gambar efficient frontier. Efficient frontier. Frontier ni barisan. Efficient. Yang mungkin start lukis gambar orang. Okay? Something. Jadi, dia kata barisan yang efficient. So, it's not that. Jadi, in finance, we need to know how efficient frontier look like. Jadi, asas kepada remember that you guys are, let's be frank, you guys are doing your bachelor degree. Okay, bachelor degree. Masa ni tengah belajar dalam benda. Okay, faham? Jadi, bila asas belajar sesuatu perkara adalah application. Start belajar dengan meniru. Okay? Start belajar dengan meniru. Lepas pandai tiru, you create your own art. Okay? Contoh, you want to become a good painter, for example. Let's say you are inspired by the drawings of Picasso, Pablo Picasso. Then, tengok Picasso the painting, oh macam ni, buruknya. Buruk tulisan dia. Pernah tengok tulisan Picasso? Tapi legend. I don't know why. Because I'm not an artist. Saya tak tahu. Tak ada brain. Jadi, at least if you are inspired by Picasso, then you try to understand how Picasso draw things, and then you start replicating. Cuba tunjuk colour dia, cuba tunjuk, ataupun Van Gogh. Yang ni antara terfamous sekali. I think Starry Nights, that's the name. Starry Nights. So, yang ni lukisan buruk. Sangat buruk, pada saya buruk lah. Tapi lukisan ni berjuta-juta value. It's very highly valued because the artist himself. Clear? Jadi, this is about drawing. So, you want to draw like Van Gogh, you need to study how his paintings look like. Jadi dalam finance kita tak belajar seni, tapi kita belajar macam mana nak lukis efficient frontier. Tengok ini, open image selected, and then below. Oh macam ni lah rupa dia efficient frontier. Tak cantik macam lukisan Van Gogh, tak cantik macam lukisan Picasso. Okay, but still this is what we have. Okay, so this is the output that you will produce. This is the drawings that you will draw using your own data. Okay, the role of this class, the role of this assignment is that to prove that using mathematical model, whatever that we do, that we use, we can produce this shape and graph that looks like this. Kita akan produce biji macam ni. Dengan pun semua sekali. But we need to show. Okay? Jadi, when you want to draw a graph, what's the basics that you need to know? In drawing a graph, you need to know, number one, the axis. Okay? Ada x-axis and the y-axis. So, what is the x-axis? X-axis adalah standard deviation, and what about the y-axis? Y-axis we have the expected return. Betul? Y, x adalah standard deviation, y adalah return. Okay, sekarang okay? Saya faham ini hampir tengah hari. Ada orang juga yang hampir berpindah alam kembali. Okay, come back. Okay, and then the next thing that you want to know adalah we want to know the y-intercept. Okay, tapi nanti kita akan go that one. But first, tengok dulu paksi. Ada dua paksi. Standard deviation and expected return. Paksi X and paksi Y. So I'm going to copy this. And then I'm going to put it in the scale. To make it bigger. Okay? So, let's expand. Now, bila dah ada graph, this is the contoh yang you want to reproduce. Then you start planning. Okay? A wise man say, if you fail to plan, you are planning to fail. Betul? Jadi, kalau tiba-tiba melukis the graph action frontier, you will end up with rubbish. You can't do anything with that. Jadi, cara nak lukis betul adalah rancang. So, how to rancang? Now, based on the thing that we have calculated before, what information do we have? Kita ada a portfolio that says the minimum return, betul? Minimum return portfolio. Maksudnya portfolio yang paling rendah return. So look at this. This is the expected return. Up here return tinggi. So bawah sini adalah return rendah, betul? Jadi minimum return portfolio adalah return yang portfolio yang bagi return paling rendah. So if this is the graph that you are going to draw, the minimum return portfolio is here. Okay, this is the minimum return portfolio. Minimum return portfolio, right? Lepas tu mana? And then, if you look here, what else we have? So minimum return portfolio done. And then we have maximum return portfolio. So what is maximum return portfolio? Maximum return portfolio is a portfolio that you cannot get any point higher than that. So we have this. This is maximum return portfolio. Betul? So 2 points covered. And then if you look at one particular point on this graph, here. Okay. Kalau dekat sini, this one. Okay. Apa beza dia? Is it the highest return? No. Is it the lowest return? No. But it is indeed the lowest standard deviation, isn't it? Tengok dekat this graph, this circle. Is there any standard deviation lower than that? Tak ada, kan? So, this is the minimum standard deviation portfolio. Did you calculate minimum standard deviation portfolio? Tak ada, betul? Tapi you calculated the minimum variance portfolio. Faham? Namanya diberi minimum variance portfolio sebab variance dengan standard deviation adalah benda yang sama. Number one. And number two, this is, I think lah, saya rasa sebabnya, when you calculated this one, when you calculated the portfolio variance, the goal is that you want to minimize the variance. When you minimize the variance, you automatically minimize the standard deviation. Betul? However, what are the things that you need to use? Satu, you look here, you multi, yang ni adalah weight, pemberat, betul? Pemberat satu, tapi satu lagi yang warna merah, the red ones, what are those? This is variance covariance matrix. Faham? Jadi, maybe because of that, I'm using as minimum variance portfolio. Okay? Boleh dinamakan minimum standard deviation portfolio, boleh juga, kan? Tapi they choose minimum variance portfolio. Hence the name lah. Okay? Jadi, in minimum variance portfolio, this is the red ones, and this is the minimum variance portfolio, MVP. Okay, now we have highest, lowest standard deviation, and then the lowest return. Betul? We have 3 points. Now we can draw a triangle. If you draw only these 3 lines, we'll have a triangle. Tak patut. Kita nak lengkung macam ni. Jadi what's next? next point we have calculated, we have what? And then you have this optimal written standard deviation and you have optimal sharp. Okay, you have optimal written standard deviation and you have optimal sharp. So, di sini, what is optimal? Saya padam ya. Okay. Draw. Okay, nampak? In this graph, dia kata tangency portfolio. Tangency portfolio. So tangency portfolio, Syafiq, comments okay. Boleh. Admin ambil. Dapat A. Siapa admin dapat A? Memang dapat A pun dia tak pernah cuba. Kalau kau betul, kau bagi kawan-kawan honest. Okay. Tangency portfolio. Kenapa dah boleh tangent? Setelah garisan, apa jadi bila sentuh berapa, dekat berapa titik? Satu titik. Apa jadi bila disentuh satu titik?
Sama.
Kenapa tangent? Dia represent apa? Dia tangent of what? Bila kita kata tangent, ni portfolio kau lekong kan? Kalau lukis sentuh dekat satu titik, dia tangent maksudnya it is 90 degree kan? And that 90 degree represent apa? Siapa boleh cuba? It represent what?
X equal to Y.
Apa?
X equal to Y.
X equal to Y tak betul. X equal to Y tak betul. Okay, siapa nak cuba? Boleh sentuh mana? Soalan dia kan tendency portfolio. Apa maksud tendency portfolio itu? Dia bersentuhan dengan lekung pada satu titik. Tapi bila kita dapat tendency itu, apa maksud tendency? It represents what? 5, 4, 3, 2, 1. Dia represent the slope. Betul? The gradient. Keturunan. Betul? Of a permukaan yang melengkung. Setuju? Setuju? Kalau bulatan was the formula IG square, betul? Betul? Then you can find the slope of the round, of the circle, betul? Macam mana nak buat? What did you do? dy dx, betul? And then you get the tangent. Maka jadilah garisan lurus. Okay, faham? Same thing apply to this one. Okay, apply to this one. Jadi lihat dalam behind finance adalah and economics adalah mathematicians. Okay? Adalah ahli matematik. So, contoh benda ni kalau nampak the formula that you calculated so far, it was first formulated pada tahun 1956 ataupun 1958. Faham? Imagine masa tu kalkulator tak ada ni. Kalkulator tak ada. Komputer dia tak ada. Komputer digunakan untuk kerang. Okay? Tak ada. Tapi somehow the mathematicians really genius. Kalau tak boleh fikir ni. Kalau aku dah tanam jagung. Tanam jagung, tanam bumi, macam ikan. Hidup ramai-ramai. Cukup masa, tanam. So, let's that. Okay, clear? Jadi tak ada siapa yang menonton bonus. At least good try lah. Dia tahu betul. Because sentuhan satu point. Good. So, this tendency portfolio, you have calculated it. Okay? Kalau dalam sini teman, it started with risk-free rate. And then we have this tendency portfolio. Sebenarnya, this one refer to the optimal sharp. The tendency portfolio refer kepada optimal sharp. Okay, clear? Okay, lepas tu kita akan ada satu lagi. One is optimal sharp, but we have another point yang tak ada dalam buku teks. Okay, kita gunakan point of origin. Yang tu pakai optimal return over standard deviation. Okay, clear? So far? kita tahu yang itulah. Jadi kita ada 1 point, 2 point, 3 point yang minimum variance portfolio, and then tendency portfolio 4 point, satu lagi ada optimal return over standard deviation, that is 5 points. 5 points yang utama. Okay, now we will draw it. Jadi, before you start drawing, you know that there are points that you have to draw. Lepas tu, you already know that what is the graph will look like. Then start planning. Cuba rancang. Okay? When you want to draw something, this point, lepas tu dia biara. Kalau this point sini, lepas tu next point ada dekat atas tu, the line akan go atas, lepas tu tiba-tiba pergi sana, pergi segitiga, lepas tu patah balik. Faham tak? It will be a haywire graph. So, what you want to do is that daripada sini, dia pergi situ, dia pergi tendency, baru sampai maximum. Faham tak? That's the sequence. Jadi, if I draw it like this, I would have something like this. We're going to start off with minimum. So I copy the information that I have calculated from minimum. So I start dari sini. So this is minimum. And then I say that we have minimum variance. So I have minimum variance, which is the MVP. Saya letak MVP lah, MVP minimum variance portfolio. Dalam NBA, MVP minimum ada most valuable player. Dalam bola, man of the match. Okay, MVP. Lepas MVP, we have what? We have, okay, yang ni nanti I will show you why. Tapi the order, the sequence, urutan dia, you akan sentiasa jumpa optimal return over standard deviation dahulu, baru jumpa optimal sharp. Jumpa optimal standard deviation dahulu, baru jumpa sharp daripada MVP. So copy and paste here. Okay. Lepas tu last kali ambil maximum return. This is the last point. Okay. So this is the sequence. Ini turutan dia. Now, tengok dekat sini. Look at the standard deviation. Look at the standard deviation to the story. Okay. Okay, look at the standard deviation to the story. You start with 20. Turun sikit. 8. Lepas tu, naik sikit. Naik sikit. Betul? Ada sequence, betul? Sini sampai sini, lepas tu dia patah balik. Because you cannot get points lower than this. Because this is already the minimum variance portfolio. Kalau dalam graph tu, this one is already the paling kiri sekali. So, dia akan naik balik. Jadi, with this point, you dah boleh draw. You can start drawing the graph. However, the graph will look ugly. Okay? Jadi, macam mana nak draw graph? Tekan draw, tekan pen. Okay? Draw graph kan? Macam tu. Betul. Siap. Draw macam tu, adik aku boleh buat lah. Okay, kita insert. Okay. Insert. Tekan scatter plot. Dengar, tekan scatter plot. Ada banyak graph, jangan main ambil, tekan scatter plot. Okay, choose the one. Okay, mula-mula ni pilih yang smooth lines. Tapi smooth lines nanti dia akan ada isu tak tepat. Ambil yang ni, sharp lines, straight lines with markers. Tekan dari scatter plot with straight line markers. Okay. So, are you with me, class? Yes? Okay. Now that we have this, ini semua tidak memberi arti apa-apa. Jadi, pergi dekat chart design. Okay, you click here. Then you have this chart design. You click chart design. Dekat select data. And you have all these. You click satu dekat sini. remove. Remove, and need to remove. Huh? Okay, I want a blank canvas. We start off with blank canvas. So, kemudian itu tak menggunakan. Clear? Lepas start blank canvas, kemudian apa? Blank canvas ada. We start with add. Letak nama efficient underscore fronting. Okay. Clear? Jadi, lepas tu ada x values, ada y values. Okay, y values, when you start doing this, biarkan y values macam itu, jangan padam. Kalau tiba-tiba, let's say for example, you accidentally terpadam y value, you also padam x value, see what happens. To create a child, you accidentally padam y value, okay lah. Then you start thinking, you want to fill up x first. Kan salah lagi, salah lagi. Jadi letak dia dekat sini satu, dia ada satu. Okay, x values. Now, x values, do you remember how does a fraction frontier looks like? Dia ada paksi x dan paksi y. What is the paksi x? Standard deviation. What is paksi y? Vector. See? The x value here adalah the standard deviation of your portfolio. Now, this is your portfolio standard deviation yang you sudah susun nicely. So you select all this, press enter, and then for y values adalah di punya return. So I highlight this return, and then enter. So you have one, and then I press OK. Lepas tu tiba-tiba dapat okay, nampak kan? So this is how your graph looks like. Betul? Cantik ke buruk? Cantik ke buruk? Buruk juga kan? Okay, now the reason why this is ugly is because we don't have sufficient information dekat sini and sufficient information kat atas tu. Jadi, your goal after this adalah after you have this graph lah, sort of graph adalah tengok apa yang saya buat kan. Okay, now this would be the story. Tengok dekat, you need to add one more column called target underscore ST. This is target standard deviation. Okay, target standard deviation. Saya dah ajar belum? Korang belum belajar pakai solver belum kan? Solver dah. Tapi solver yang resolve belum lagi kan? Okay. Jadi, tengok dari sini. Kenapa your graph looks buruk? Okay, is because at least my graph looks ugly. Is because from 20% tiba-tiba tu drop dari 8. Tapi yang daripada 8 sebelah atas dia nampak cantik sebab 8 dari 9 dari 10 dari 15. So the point dekat. When the point is close to each other, then the graph can be plotted nicely. Tapi when it is like too far, the points are too far, dia akan sangat tak cantik. Jadi to make sure that it looks good, okay, cara dia adalah we need to figure out the distance, jarak yang sesuai. Jadi macam ni 20. Okay, if I do this, saya dah tahu dah. The last point adalah 800. Okay, 800 this is like the lowest standard deviation. And this is the highest standard deviation that I have, 20.59%. So what I will do is that saya dapat equal 20 tolak 8. Saya dapat equal 12% distance. Jadi what I will do is that lebih kurang. Kalau saya bahagi 2, maksudnya if I do this 12% bahagikan dengan 2, jadi saya akan lebih kurang 6 point. 6 point. So what does it mean? It means that antara 8 dan 20 ni akan ada 6 titik baru that I will create. Okay? 6 atau 5 lah, kisah saya. Dia tak kena banyak juga. So saya buat 6 lah. 1, 2, 3, 4, 5, tu kita ada subtraction 2, 3, 4, 5 je. Okay. Boleh lah subtraction 5 lah. Okay, saya buat 5 lah. Okay, 6 atau 5, saya lebih kurang. So then, tengok dekat sini. Now, the starting point is 20%. Okay, this is 20%. Bawah sikit daripada 20%, let's say I start with 18%. So, tak ada semua tak dalam. Target 18%. 18% bawah sikit, tolak 2%, 16%. Bawah sikit, 14%. Bawah sikit, 15%. Bawah sikit, 10%. And then lepas 10%, we will have this 8%. So 10, 8 dekat. So fine. And after this 8, tengok. Kalau kita sini, this is the story. And then this one is this, sama. Okay. Lepas 8%, we have this, in my case, 9%. Lepas tu, up lagi, 10%. Lepas tu, this one is 13%, kan? Jadi 13%, still too far. So what I will do is that I will create a gap. Saya akan cut this one, saya letak dekat sini. Jadi sini letak 12%. Okay. Lepas tu sini sama dengan. Okay, now based on this, remember that this is the plan that I draw for me. Saya start dengan 20, turun sikit 18, turun 16, turun 14, turun 12, turun 10, 10 turun 8. This is the lowest point. Lepas 8, naik balik 9, naik sikit 10, naik sikit 12, dan last kali 13.8. Lepas 13.8 dah tak ada sebab this normal on the efficient frontier. Dekat lebih situ pun sama tak ada juga kan. Jadi kita ada sini pada sini saja. Okay. So now we want to plot it. Kita plot lah. Kita have this. Okay. Jadi daripada yang this one. Okay. Jadi those that are here, ada target dekat sini. Those that are here, this is what we have to find using solving. Termasuk sini. Okay. So atas sini, between minimum return and MVP, everything in between here, this is what we call sub-efficient. Maksudnya dia tidak efficient. Tapi in between here, this is what we call efficient. Efficient. Underscore 1. Okay. So saya ada satu je. Okay. Your case, your data, you might have a greater distance between the stocks. The portfolio, lepas tu you mungkin kena letak dalam 10 macam tu. Lebih kurang. Are you with me? Masih lagi? Masih lagi ya? Seorang faham pun tak faham pun. Saya jadi seorang. Okay, yang lain semua nampak okey, nampak bela juga. Nampak bela ngantuk. Good afternoon. Oh, it's afternoon, right? Indeed, it is afternoon. Okay, so good afternoon. Shall we take it next? Not now. Okay, so now we're going to draw. We're going to find the point here. Jadi macam mana nak cari point dia? Jadi kita kena pakai solver. Okay, for sub-efficient. Dengar betul, for sub-efficient. Ada 1, 2, 3, 4, 5. In my case, there are 5. I will be using minimum return. So I copy minimum return all the way from the beginning all the way to Sharpe ratio. I paste dekat bawah ni. Saya paste kat bawah ni. And I will paste sini copy. I will paste everything sampai sini. And then will highlight dekat sini. Okay. Now can you see everything here adalah 20.594, betul? All certification are 20.59540 because we copy the value from the minimum return portfolio, betul? So kita copy dan paste, that's all. Jadi untuk this one, all that we need to do adalah buat solver, use solver. So go to data, solver, and reset all. Reset all, yes. Okay. Okay. Now, the goal, objective here adalah you want to set the return. So this is the return. I select this one, select return, enter. What do I want to do with the return? Because this is sub-efficient. Sub-efficient. Saya letak minimum. Saya nak tunjuk kenapa sub-efficient. Okay, do you know what is sub-efficient? Faham ke apa itu sub-efficient? Efficient apa efficient? Efficient bagus apa? Sub-efficient tak bagus. Berapa ramai student banking dekat sini? Syafiq berapa? Banking. Finance. Siapa banking? Banking. Okay, banking. Pernah dengar perkataan subprime crisis? Subprime crisis, global financial crisis. Okay, global financial crisis pernah. Global financial crisis started with subprime crisis. Okay, kenapa nama dia subprime? Subprime adalah prime over prime, bagus, bukan prime, tapi bagus lah. Subprime adalah tak bagus. It started with subprime crisis. What is subprime crisis? It is subprime lending. Subprime lending kenapa? Ia bermula dengan bila bank, remember that, for banks, lagi banyak dia bagi loan, lagi bagus, betul? The greater loan that the banks give away, the greater asset they have. Betul? Setuju? So, dia bagi dia loan banyak sampaikan orang yang tak layak pun dapat. Orang yang layak, betul-betul layak, we call them prime borrowers lah. Yang tak layak ni dikira sebagai subprime. Tidak layak. Jadi, in this efficient frontier, up here sini semua adalah efficient frontier. But starting from this point ke bawah, this is sub-efficient. Jadi bila sub-efficient frontier, the goal is not to get the highest return. Rather than that, the goal is to get, this is the return, the minimum return. This is the return and we want to get the minimum return. Okay, now, by changing cell, sama macam sebelum ni, by changing cell, select this, set for weight, enter. What is the constraint? Sama juga macam sebelum ni, the constraint, the total weight, this one must, the total weight must always equal to 1. Okay? Okay. Okay, if you have this information alone, dia akan jadi nanti, dia akan jadi ada apa? It will give you the exact same answer as what you did for minimum return. Jadi, you have to add one more constraint. Satu constraint, especially. The constraint is you need to select the standard deviation that you have highlighted. This is standard deviation. Select must be equal to. Standard deviation must be equal to what? Equal to the target that you have set. Macam untuk row ni, the target is 18%. So target 18%, enter, and then I press OK. Then I just have to check. Atas ni 13, bawah ni 13 dan 13, sini 13, sini 13 dan 13, everything is row 13. Then I know that everything is correct in place, and I just press solve, and then OK. Look at the answer, and look at that. Sekarang ni yang tu dah jadi 18%, betul? Dah jadi sama macam target kita 18%, betul? And then moving on to the next one, Data, sofa.
Ni tengah
Saya letak nombor 14.
Ni tengah mana?
Dek ini.
I change this one.
Ni dah.
14, change this one, 14. Change this to 14. Okay, change this to
Kok tu salah.
Salah.
Add di mana dulu. Tu, ini.
okay. And then I solve. I solve okay. Sekarang ni jadi 16. Saya continue lagi. So,
Ni mana?
jadi, okay, korang semua boleh buat pakai data korang. Please use your own data. Practice. Saya dah buat benda ni berpuluh kali. Sampai dah 100 kali, 100 kali. So,
Ni.
Betul weh.
Betul.
Speaker. Tu betul weh. Steady deviation.
Standard deviation.
Tidak betul.
Total weight sama dengan satu.
Okey.
Tapi satu lagi maksudnya adalah standard deviation. Standard deviation tidak sama dengan target.
Tu yang highlight
Standard
sana.
deviation.
Tadi kan?
Minimum. Minimum
Kita
ada.
nak tengok data. Data kau macam mana?
Tu, betul yang ni. Ni. Kan ni.
Kau tanya kau ni.
Highlight yang ni. Garis ni.
Ni garis ni.
Lagi. Enter. Okey. Atas tu betul tak?
Betul.
Kenapa tu? Hai, yang ni patah kepala ni patah. Jadi muffin. Highlight extended duration. Highlight extended duration. Semua.
Semua ke bawah? Dia apa ni nama?
Dia jadi dalam biasa. Ni jadi cantik.
Ada soalan? Ada. Okey. Adik Amalina. Okey. Clear. Okey. Okay.
balik je. Allah buka orang takkan dia.
Satu lagi ke?
Ya, memang satu je.
Thank you.
Huh? Ya. Tak efisien lah. Kita nak beli, kita nak tanya.
Dia nama ni tu.
Ni efisien. Tak efisien.
Aduh, ini satu.
Mana ada orang dapat MVP? Oh, real lah. Sub-5. Sub-5. tengok. Tak payah tengok. Tak pernah tengok. Oh, ada subscribe. Macam mana buat subscribe?
Kan 14, 16,
Ya.
14. Kita kata dua.
Okay, class. Okay. Okay, for sub-efficient frontier, your goal is to minimize return, betul? Minimize return, and then you have this target. Kalau dah sampai dalam minimum. And then after that, in my case, I have this 9 and then 10, but I only have one efficient frontier. For this one efficient frontier, jangan copy daripada minimum return. Okay, before this, for all sub-efficient, you copy from minimum return, betul? Now, I want you to copy from maximum return. Saya dah cakap belum kenapa? Did I say why this one I have to copy from maximum return? Belum cakap kan? Dah cakap tak? Belum. Ada cakap pasal globe? Ada? So, tadi kelas ada actually. Apa dia cakap pasal globe? Ada? Ya, so kelas tadi lah. Okay, now I will let you know. Okay, do you notice that when you start doing the efficient frontier thing, you have to use the solver, betul? When you press the solver, komputer tu macam delay sekejap, betul? It was a sort of like thinking. Do you remember that we use the enable iterative calculation? Yang ada 10,000 kali tu. Enable iterative 10,000, betul? So, that is saying that Excel are given 10,000 trial, 10,000 percubaan to get the right answer. Jadi, when we have a complex portfolio, kalau, for example, imagine this. This is efficient frontier. Tadi sub-efficient frontier. Sub-efficient frontier, if I draw the sub-efficient frontier, when you use the minimum variance, the minimum portfolio, okay, minimum return dekat sini, kat biru, this blue dot. And then the one that you calculated just now, it refers to here, and here. Everything here tidak jauh, it's not far from the minimum portfolio. Jadi, when Excel start to find the answer, they can start from a point that is closer to the actual answer. Jadi tak jauh untuk Excel tu berfikir. But if you give the answer here, contoh, dia akan show you bila kita start pakai chop sanding. Let's say you give the starting point here, but what you want to find is down here. Jadi Excel tu kena pusing down, pusing sini, baru jumpa sini. When Excel has the way that Excel has to find the answer is too far, terlalu jauh, maka besar kemungkinan the 10,000 steps tidak akan cukup. Satu, tidak akan cukup. Number two, it will give you a wrong answer. Kita bagi jawapan yang sama. Faham kan? Okay, sebagai contoh, analogi dia. Let's say I ask you to play a game. Saya suruh main game. Game dia adalah mencari barang tersembunyi. Okay, find hidden item. What is the item? The item is a globe. Tahu tak globe? Globe yang ada gambar kita tu. Find the globe. Tiba-tiba dia nampak, betul tak? Kau cakap, saya bagi masa 1 minit. Mama tu jumpa. Kau nama apa? 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 Amar. Ke Alfa ke? Alfa ke? find the globe. Tapi globe tu saya letak dekat SCFB. Bagi masa 1 minit, boleh jumpa?
No.
Tak boleh jumpa, betul? Jadi korang kena jalan 1 minit tak dapat. Sama macam Excel. If you give the wrong starting point, then 10,000 steps might not be enough. Okay, so with that said, untuk efficient frontier down here, this particular point, copy the answer that you get from maximum return portfolio. Okay. Copy from maximum return portfolio. And then sini nombor berapa? Mine is kat sini nombor 21. So saya buat dia 21. You go to number 21. I want to maximize it, maximum by changing cell 21. This one 21. Change. This is 21. Okay. Change this one 21. Okay. And then this one 20%. Okay. Tapi remember that this is maximum, bukan minimum. Then press OK. Dapat jawapan sini 12%. And look at, okay, now tengok betul-betul. Tengok betul-betul. Sini 12%, betul? Sini juga 12%. Atas ni 12%. You got 12% standard deviation. Bawah ni 12%, you got standard deviation, betul? However, look at the return. Yang ni return 9%, yang tu return 1.16%. Risiko sama? Sama, betul? 12%. Standard deviation is risk. Standard deviation risiko. Risiko sama. Tapi satu bagi 1.1%, another one give you 9%. You nak pilih mana? 9% atau 1%? Mestilah 9, betul? Sebab tu 9 itu efficient frontier. Yang satu itu sub-efficient. Clear? Okay. Jadi once you have done all this, you dah lengkap from here all the way down here, then you can go to your graph. Suddenly your graph looks beautiful. Kalau your graph tak update, boleh pergi update manually. Go to here, chart design, select data. You can go to edit. Okay, name doesn't have to change. For the X value, I just have to highlight this area. Okay, Y value, ada. I just have to highlight the detail. Okay, enter, then okay. If you manage to plot it nicely, the increment is nice 2%, 2%, or 4%, 4%, or 5%, 5%, depending on your data, then it will look nicely. It looks like a nice curve. Faham clear? Kita dapat tu. So far so good. Okay. Next is selepas ini pukul 12.22 saya akan ada satu pakai cup. Okay. We now have kita bawah kanan ni capital allocation lines. Okay, we're going to draw the capital allocation line. What is capital allocation line? Okay, if you look at this graph, what is the capital allocation line? Capital allocation line adalah this line. Garis lurus. Perasan tak? There's from this period here, it touches the tendency portfolio all the way up. This line, this straight line is called CAL or capital allocation line. Kita akan draw this capital allocation line. How to draw it? Senang sahaja. We know that that line is a straight line. apa-apa sahaja garis lurus, dia punya formula adalah y equal to mx plus c. And if you look here, risk-free rate. What is the return for risk-free rate? 2.91%. Huh? 2.91%. What is the risk for risk-free rate? The risk for risk-free rate adalah 0. Kenapa 0? Risk-free. Tax free. Tak ada tax. Risk-free. Tak ada risk. Tak ada risk. Maka standard deviation dia sama dengan 0. When standard deviation is equal to 0, this point represents what? It represents the apa? Dalam matematik dia orang panggil y-intercept. Betul? Pintasan y. Okay? So, what we have here is pintasan y. Jadi, we will have the two things. For capital allocation line, we will have this risk-free rate, risk-free portfolio, risk-free portfolio, and you will have 2 points. Satu, return. Return is y, and then you have standard deviation. Standard deviation is your x. Okay. So risk-free rate, risk-free portfolio, that's one. And look at the tendency portfolio. We have this tendency portfolio. Apa yang saya cakap tendency portfolio ni? This is your optimal Sharpe ratio. Optimal Sharpe portfolio, okay? Optimal Sharpe portfolio. Jadi kat sini kita ambil optimal Sharpe portfolio. S-H-A-R-P-E, bukan Sharpie. Sharpie itu pen mata. Sharpe is William Faulkner Sharpe. Nama dia. Dia pemenang Nobel laureate juga. Menang Nobel. Jadi comics. Okay, so risk-free portfolio. We know that what is the return for risk-free portfolio? The return is 2.91%. What is the risk for risk-free portfolio? Risiko untuk risk portfolio mestilah 0. Betul? 0%. What about optimal Sharpe? So, have you calculated optimal Sharpe? Mestilah pernah. Kita cari balik apa dia punya return. Optimal Sharpe dekat atas ni, bawah sekali. In my example lah. The return is 8.5%. What about the standard deviation? I go and find that one. Standard deviation adalah 10.61 Okay. So far so good. So far we have this information only. Okay. So can we draw the line? Boleh. Kalau masih tak banyak, aku tanya dulu. Jawapan dia boleh. Draw the line. Macam mana nak draw the line? Senang dia, cari slope. Macam mana nak cari slope? Slope is m. What is the formula for m? y2 minus y1 divided by x2 minus x1. So you have 2 points. y2 minus y1 close the bracket divided by x2 minus x1 and close the bracket. We got the slope, and the slope is the slope bukan dalam percentage ya. Slope is just a number. Okay. So slope is 0.52. It is a multiplier for sensitivity. Slope is okay. So we have these 2 points. Now what happened? Now I can draw the line. Where is the graph? So this is my graph. Now I'm going to add more points. Di sini chart design. Select data. You have one efficient frontier, right? So you select one more. Add. The name is CAL. Capital allocation line. What is the x value? Go and find where did you write this one. X is this 2. Select. Okay. What is your y value? Y value. Padam. You select this 2. Good. And then okay. Then okay. And let's go back to your graph. It looks like that. Nampak cantik ke? Nampak tak cantik. Sebab apa? Tak cukup cantik. Okey lah, tak cukup cantik sebab look at this graph. It touches and then extend, betul? So you need extra point. Jadi nak dapat extra point, macam mana? You need to draw the third point. Sini extra point. Remember that the equation y equal to m darab x plus c. So y equal to m apa slope, betul? Open bracket. M slope multiplied by x. What is x? X would be something that I put here later on. X, close the bracket, plus c. What is c? C is y-intercept. The distance. Enter. So far, extra point is that. Now, I can change to whatever value I want. So let's say I letak standard deviation equal to 20. So this is 0.2. 20%. So 20% that. Jadi, when I look at my graph, it looks like that. But I just have to select data, edit this one rather than 22, 21 it extends to 22, this one extends to 22, and I press OK, so I look at the graph, dia dah ada sampai sini. Okay, if I tarik ke bawah, zoom in, you can see that it touches at one point only. Satu titik, betul-betul tangents. Okay. Selepas itu, maka sudah pukul 1 hari. Jadi kelas korang saya tak sempat habiskan yang ni. Kita kena sambung kelas satu lagi. Siapa ada kelas lepas ni? Aku ada kelas. So, don't jumpa next class. Okay, hari Isnin. Okay, terima kasih. Datang lagi.
Coba jatuh.
Okay, siapa tak scan ni boleh scan.
Kenapa ambil itu?
Ni ada ribu betul tak? Ribu betul tak?